Problem number 2095. Delete the middle node of a linked list. You are given the head of a linked list. Delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is the n divided by 2 node from the start using zero-based index, where x denotes the largest integer less than or equal to x. So for n equals 1, 2, 3, 4, 5, the middle nodes are 0, 1, 1, 2, and 2 respectively. For n equals 1, the middle nodes are 0. 2, it will be 1. 3, it will be 1 as well. Okay, so it's 5 will be 2. So 1, 2, 3, 4, 5. It will be this middle node. Okay, so I think if if it's if n is an odd number, it doesn't have a problem. So sorry. Yeah, it's like 1, 2, 3, 4, 5, and then we should delete 3. And if we have 1, 2, 3, 4, then we will delete we'll delete 3 as well. Okay, so if we have only 1, then we will delete 0 and delete 1. Yeah, so we should get here like yeah, since the middle node makes me think of 2 pointers, and every time there will be like 2 pointers, and every iteration 1 pointer will move 2 steps, the other will move 1 step. So it will be like yeah, we'll have at first will be here, the start, and then this will move 1, and we will move 2 to here. Then we will move to empty. Then we'll move to here. Yeah, we should delete this one. but if we need to delete, yeah, if we can delete this by assigning the next value to the here, and yeah, it's okay. Then let's see if we have an odd number, it doesn't work. Okay, we will have starting 2 pointers starting here, and one will move 2 steps, 1, 2, and the other will move 1 step, and then it will move 2 steps to the last node, 1 move here. Okay, then we will delete this. Okay, start. Time complexity will be since we only move 1 round, so it will be ON, big ON. So we'll have a slow pointer and fast pointer equal to head. Then we will start moving while the fast node reach the last node, or at the it's empty, then we stop. So fast or end fast next has value, then we will still move. So yeah, fast will move 2 steps and slow will move only 1 step. Then then after this the slow pointer will be pointing to the node that we should delete, so we will assign slow value to its next value, and slow next will be assigned to its next value. Okay, then we will return head. Okay, I think we should try run some edge case like like 1 and maybe 1, 2. Yeah, there's two kind of cases. And for 1, we will have slow and fast here, and then while fast has value, fast next is already empty, so it doesn't meet the condition, so we will run to here. So okay, slow value will be slow next value O. This already is none. Oh wait, if okay, if slow next is exist, else we will have I think we will write it here. If slow next exists, return head, else we will return none. Yeah, since this we should delete 1, then we should return none. Okay, and then if 1 to 2, so first of all we'll have the pointers here at the start, at the head, and then fast has value, fast next has value, so we will run this 1 step, 2 step, and then slow move 1. Okay, so if slow next, okay, slow does not have next, then we will return. Oh. Yeah, both two conditions does not have slow next, and we should point or okay, maybe we can have a proof, like yeah, because we may delete this node, so I think we need a dummy node. Then yeah, we will have proof dummy equals this node, and this next is head. Okay, so when every time moving, we will have also move 1 step for proof, and yeah, when delete we will use proof next is proof next. Or maybe slow next. Yeah, but I think slow next will be better. Okay. Then we will return dummy node next. Yeah, let's see if we'll have a proof. Yeah, we will have it like let's say O. Let's say dummy. Have 1, and yeah, we'll have both here, and we will not run into this condition for this because fast does not have next, and so we will have proof next equal to slow next, which is none. So proof next will be none. This will be none, and return dummy next, it will be none. Okay, correct. And then for this we will have dummy, so we will have proof here and slow here, fast here. Okay, so we will run once for this iteration because fast has next and fast has value. So fast will be none. Let's move here. And then proof next. Okay, proof next. Oh, proof will move one. So we'll move one. Proof will move one to here. So then we need to delete 2. So proof next equals slow next, which is none. Okay, so then we'll have dummy next. Yes. Okay. Okay, it's fast. Now kind of slow. Okay.